and thanks for coming. I think I know most of you, so I like have a captive audience of friends. So that's really helpful because I'm really nervous. So now that I just like know that it's mostly all my friends here, that's great. I just want to go over some things that's like, sort of lots of people here are involved in Jupyter-based teaching. This is something that I've been doing for a while and sort of like, just keeping you up to date on what's happening in the field. I think that I had like a less ambitious title, but Tien was like, you need to make it really punchy. So I got cutting edge in there. Yeah. Gotta upgrade my title to make it sound like super exciting. Learning, somebody from Learning Lab was like, make it more exciting.
Very sharp.
Well, that's why we're here. You have people in the room.
Here we go. I'm super nervous, and I have some live demo in the Jupyter Hub to show you. So I'm going to show a bunch of it in screenshots and slides, but then hopefully I could just jump over and show it to you so you get like the teaching live stuff. But some of the things are relatively complicated, so bear with me, and hopefully the Jupyter Hub's running. So I'm going to have a few different topics. One is just new ways to access Jupyter. What are we doing in this space, and what do I think is like what's happening in the next few years? I think there's a potential. I'll always say this, but Jupyter's like revolutionizing a field of education, and some things that are coming down the pike in the next couple of years are going to be big there as well. Then I'm going to show some examples of GIS and mapping examples. I'm going to show some examples of API and like pulling the data directly in. So sort of this idea of live data that I'm pretty into. And then finally, at the end, the idea of using small language models in Jupyter that I'm pretty excited about. And this is, I think, will be our play. Lots of people are like, how do we teach AI? What's happening in the AI space? What are you doing? Everyone's like, respond to AI. And the NSF was like, AI classroom. So this is what I want to do in this space. So we can talk about that. And hopefully we can get the language model to talk to us in Jupyter. All right, I've been teaching and building Jupyter-based curriculum for 7 years. It's like a mid-career life shift for me, just even the learning the Python, but learning about Jupyter had been happening at UC Berkeley, and I went to a professional development workshop with faculty from across campus. And I was like, this is awesome. And it lined up with stuff that I had wanted to do as an economics professor. I was like, I want to make this interactive, and I want to give students an opportunity to make the choices that go into the models. And I had always sort of imagined that, and it was too much coding to me. And when I saw, too much coding to code it up in JavaScript yourself. And then when I saw what Jupyter could do, I was like, oh, they just made a whole front end to do this for me. So I really got involved with the Data 8 people, and the Data 8 people had a whole open source approach. So I learned a lot about open source software. And so a lot of this building curriculum as open source software, delivering curriculum as an open source software project is stuff that I've been learning. What I teach is data science and economics. That's my little niche. And so I teach a fall and a spring class that's data science and economics. And I'm passionate about having interactive computing as sort of like the framework for the class. Not doing any math that's not in a notebook. So I'm sort of like far over on the side of like everything's in the notebook. I go through notebooks and lecture. They do all their homeworks in notebooks. Anybody here Unit 18 lecture? Probably not. I met at the poster session, the Unit 18 lecture at the poster session. If you know about Unit 18 lectures, we teach estimates vary, 30 to 50% of the student credit hours at the UC. If you get to 12 semesters or 18 quarters, you get an excellent review where you could go to become a continuing lecturer. And this is my 12th semester. So wish me luck. I really love teaching. I also have a staff position at UC Berkeley where I interact with a lot of you guys. And, part of that's building community around data science education. But my staff position before there was like this idea of like California Alliance and stuff was about supporting faculty to teach with Jupyter. And so like, what's it like to support the infrastructure behind it? And what is it like to do the professional development with faculty? And I ran a lot of professional development. I had gone to this workshop and had my life changed. And then I took over that workshop and started teaching that to other faculty. And now I teach every summer at a professional development workshop in June. If you're interested, you can come. Many of you in this room have been to that workshop. If you're interested to follow up with that. But there's a lot of the body of this work that I will touch on today that's from a project called Data Science Modules. And this is a giant library of open source materials that have been developed for a whole range of classes. Super funny. There's somebody here at the workshop who's the lead biology instructor for a 700-person class at UC Berkeley, Bio 1B. And they have a lab that has to come out next Monday. So like on the side, I'm like patching the notebook for Bio 1B. That's one of our most successful modules. So 700 people take the class each semester, and it's been taught for something like 4 years. So if you add that up, that's like one of the largest numbers of students that we've gotten teaching with notebooks, So I'm still supporting that. I also support this idea of the infrastructure for the Jupyter Hub across California and support people at community college who want to teach with Jupyter notebooks. And this has been a project for the past few years with CloudBank, which is a project of UCSD, and 2I2C, which is a nonprofit that spun out just to support this. And so multiple of our colleagues here are using that to teach their class today. And very excitedly to announce that Learning Lab has seen this initiative and decided to fund it. And there are stickers and flyers up here for your water bottle or your laptop. And the idea is we're going to keep building this and keep building Jupyter hubs for community college and CSU is the main target across California. And we're going to put together we're going to add to that this idea of the modules, like a notebooks library, where people will be able to teach, out in other subjects. So we have stuff in physics, we have stuff in biology, and we have other examples I'll show you with like GIS. So people will be able to, get stuff out of that library. Hopefully people will contribute to that library, right? So, that's like, how do you create that ecosystem where people are checking books out of the library, but putting books in the library too? So that's work to be done in the next 3 years for this grant. But it's launching now. If you're a legacy partner, you will still be supported. But, if you're a new partner, come on board, and there's a form that you can click on to join us here. Now, this is what I want to talk about a little bit. This is what I think is probably going to be the future for education, right? So Jupyter Lite is a project that they're working on very hard, and they are going to build a version of Jupyter that's going to run completely in the browser. And so everything is so the browser, Chrome, can translate everything through the JavaScript. So they have translated Jupyter itself and the kernel, the Python kernel that runs it, to interact with the JavaScript that the browser has, right? And they are going to be able to launch, and this is a really good use case for education, right? So you build it right, you build a GitHub repo right, like we teach our classes now, a few extra bells and whistles, and the class just launches, and the laptop itself is handling the compute. But you still have the zero install. Like, one of the reasons that we're so passionate about Jupyter is the zero install. Student walks in, they're computing immediately. There's no set it up, there's no debug, there's no I have to get you the file, right? It just shows up in their browser. And so that, like, lowering the friction to get people start computing is something that we super believe is like a part of our success. And Jupyter Lite is going to be able to do this. And we are going to be needing to work in the next few years to adopt a whole bunch of our curriculum to like have a workflow to Jupyter Liteify like data 8 and modules and stuff. So, what's it gonna take to, like, a new instructor makes a new notebook that they're excited to teach about, and for them to like be able to quickly jump over those steps and distribute it with an interact link that the students will get it immediately. Exciting examples in this space. So Course Kata, people have heard of Course Kata, based at UCLA, psychology, former Learning Lab grantee. So they have a curriculum that's a pretty like extensive curriculum, right? It's not just a set of notebooks. There's like integrated with a textbook and professional development. So they have a curriculum. And they need to like keep scaling that, and they're sort of dependent on like a Jupyter Hub administrator at UCLA, but they want to be able to teach at high school in like different places. So for them, like they need to escape from the confine of like servers and logins and sign up for accounts, right? So if they could get Jupyter-Lite to install, it's going to really like dramatically increase the impact. Anybody heard of Skew the Script? Skew the Script is an amazing thing. You should look it up or like look for a blog post. This guy is named Dash. What's his last name? Dash is amazing. So he's a AP stats teacher in San Antonio, Texas, low resource, underrepresented students in high school AP stat. And he did these awesome lessons that like are really engaging to the students. And he's like completely winning. And he's one of those people you're like, you're amazing. And then he does a thing where like, so the AP exam is like in May, and then there's a month after the AP exam until students get out of school, but they have all these skills. So what do you do with that month? And a lot of times in high school, it's a wasted thing. So he's like, let's have a project and let's enlist these people. He has all these high school teachers that are like, yeah, let's go Skew the Script. And so he's like, let's give them a project where they can explore in R something and apply what they've learned. But how is Dash going to get like 1,000 or 10,000 or 100,000 high school students computing, right? And he got money from the Gates Foundation to sort of work on this and build this like Jupyter layout for high school students. The people that are developing this, and I just met with somebody last week from Quantstack, was visiting Berkeley, the core Jupyter developers, like people that like are making the Jupyter core kernel and developing the project. They are in France, and they had these huge projects with the French government where like all the French high schools are going to teach like little lessons like applied math. And so they have been using Jupyter-Lite and got French Department of Education funding to get like, I think it's like physics lessons and applied math lessons. And they're also deploying it through this. So this is like, how do we get to like lots and lots of, this is a bigger, I'm like California higher ed. This is like going to top out at like, tens of thousands of people, but these are like, hundreds of thousands of learners, so that need this approach. Hopefully my pitch is, hopefully these folks are going to move the technology forward and like take it a couple next steps. And then we as educators who are already using Jupyter are going to be able to use this to like make our stuff, put it in online textbooks and like, anybody can interact with the code. So next couple of years, hopefully we're moving our stuff in this direction. Hopefully the Data 8 textbook, the things just live compute in the textbook, using this technology. All right, so some examples. CalEnviroScreen, anybody? Okay, everybody go to CalEnviroScreen. So best, awesomest data set has census tract level information in California, a vector of economic and pollution indicators, and it sets up a pollution score for every census tract in California. You can go and download this XLS and start making data science lessons tomorrow. Like if you want to do some environmental justice or bring something interesting into your class, there it is. The reason I have it in here is a lot of people use CalEnviroScreen. There's curriculum built on already. They also released the shape file. So at the top, like you start with the XLS file, read that into Jupyter and Pandas and do data manipulation. There's also the GIS files are available. So in this notebook, you could be like, all right, pre-process the data, pick a variable. Pollution burden score and pollution vulnerability score are these two scores that are like the outcome of these matrices, these different features that are combined into like a combined feature. So the students can be, and this is relatively complicated to get, students' ability to like move between, table data into maps and back and forth. But GeoPandas, it's all set up and you just downloading like a file from the state to start that run. What I say in my class that's super interesting is like they have passed SB 535. California has cap and trade. So we have basically people pay to pollute carbon in our state. One of a few states that does this, one of the biggest carbon markets in the United States. And so the revenue that's generated from California cap and trade is mandated, some like 20% of it or something like that needs to go to disadvantaged communities. This tool is steering billions of dollars in cap and trade money, right? So this is real life, like carbon, climate change today, vulnerable poor populations in California. There's a lot of like lessons that you can really connect things to that are motivating here. But adding the mapping there It's just like another superpower instead of just looking at tabular data. And they do have a mapping tool, so you can go to the website and do the mapping without being in the Jupyter notebook. So it's like sort of nice because you're like, oh, here's the things you can do in the mapping, and then you're showing them that here's how the tools work so that you can do it in Python. So sort of like on-ramp or like motivation to learn GIS. So this is one from my class. This is from a combination of like WikiLeaks, Panama Papers, multiple of these sort of like leaked financial instruments data. And these are folks from the EU Tax Observatory. That one of the lead authors whose website this on is the best name ever, Blueberry Plant Rose. I still am waiting to meet them. And they have a data set that has 800,000 properties in Dubai, and it has $146 billion in foreign wealth that's invested in those properties. So a global center for money laundering, from corrupt, rich, wealthy, people diverting the money from wherever they're supposed to be. And in a lot of cases, it's like corrupt government officials. That's who launders money, is people who are like wealthy and they need to get their money out of their country, and they invest it in London or Dubai or a few other places. So they did really complicated thing with the data set, and then these guys put it out based on like a bunch of leaked data, but they cleaned it up and put it out. And then what's interesting is you can ascribe the country of origin. So this is like looking at these different countries and how many billions of dollars some of these very poor countries have. Some of them like much bigger than their budgets, invested in condos and luxury homes in Dubai. I will say that my TA for the class was from Dubai, and he took this on and made the project. But this is just a nice one where like working through giving students access to a giant data set, and then they had to do some like pandas wrangling to set it up. And then, but at the end, you get an interactive map to sort of like illustrate the outcome.
How do you know these samples are not biased? There are a lot of parameters here involved.
Yeah.
People are not transparent regarding what they have. That's an example. But this biasing thing in any data set
Super.
is
Yeah.
probably.
In this case, yeah, I mean, so there's a funny thing where you get, so if you list the top 5 countries, like by wealth, some of them are like St. Kitts and Cayman Islands, right? Where you're like, oh, well, that's just because somebody has an offshore bank account. They just covered their tracks a few steps. It doesn't say Mozambique, it says St. Kitts because first so there's clear biases where like you can only track it down so far, right? I would say in this sort of like trying to be transparent about corruption, a little bit of transparency goes a long way. Like, yes, it's biased, but this is more useful information than anybody's ever made public before, right? So what's your goal? Your goal is like illustrate to the world the extent of the problem. And we have no governance on keeping track of this. And Dubai doesn't care who launders their money there. Like that's what you're trying to do, is get like political will to deal with this. And these guys are from EU, and their specific mandate is like people dodging taxes in EU. And should the EU have better rules about wealthy people hiding their wealth? So yeah, it's biased, but showing the scale of the problem to generate political will, that's probably what they're trying to do. So yeah, you're not like, and this should be anonymized, and you shouldn't be like individual people. There's other projects that do track individual people, like Russian arms dealers that are like involved in this conflict. Like that's another part, like de-identifying corruption in places that you want the government to like take this on, like find that guy, that's a different strategy. This is anonymous, just like property and country of owner. Okay, here's another one. So another part of Cal and Virus Screen is that there's a professor from Berkeley, Rachel Morello-Foch, has been involved in sort of GIS and mapping poverty over time. This was for her class. This was a really interesting one where there's a national data series on tree coverage in America. Like somebody came out with like, at some pixel layer, you can see sort of like the pixelation here from satellite imagery. What's the amount of tree cover in America? So that data series was there, and we could read that in. Then the other data series that we pulled in was on the Hulk maps, the redlining maps. People know about that one? Common, people teach about it. These are maps about racial redlining that are nationwide. And there's, I think, 6 urban areas in California. So it's like Bay Area, Fresno, LA, San Diego. So we have these maps from the 30s on racial redlining. And the New York Times, this is based on like the New York Times did a huge story that was based on heat and temperature. And they showed that redlined areas have like, 2 or 3 degrees more of heat. So this was like, could we do something like what the New York Times did, but with this other data series that was just out there that was called trees, so that was on tree cover. So could we basically look at like, are the places with more tree cover, like more trees planted, the neighborhoods that were in the Hulk area green, that was the whiter neighborhoods, right? And poorer neighborhoods have less trees. Right. It's obvious, it's not something super clear, but this is like teaching about environmental justice and bringing in 2 different data sets and like overlapping them and giving a score of how much they're overlapping and showing what the differences are. So again, data science modules in this kind of class, people aren't there for coding. They're not there to actually learn GIS. The professor knows a lot of GIS. The professor does like, advanced research in this area. But the students in the class, it's a general class that's like Berkeley has a set of classes called American Cultures classes that everyone has to take, like ethnic studies requirement. So students in the class don't know how to code. They just know how to go into the notebook and run the cells. There's a drop down if you want to change the urban area from, the Bay Area to LA, you just deal with that with a drop down. So it's pre-coded, but the students are still being exposed to like, this is what the data set is. This is us reading it in. In the future, another project that's getting worked on is Jupyter-GIS. We have one of the founders of Jupyter, Fernando Perez at UC Berkeley. He has Schmidt Center for the Environment, and they're working on open source GIS tools. So Jupyter-GIS is like a response to sort of the corporate monopoly of ArcGIS, right? Everything GIS is in ArcGIS. It's very expensive. What the university does is like train people to use a tool, and when they leave, they have to like have the license to that tool. The Python community, scientific Python community, has done a lot to do QGIS, which is an open source like analog to ArcGIS, and we can teach classes in that, and people are learning open source. But there's still a lot of like setting up the environment and having the files in the right place and stuff. So you're not getting that ability that Jupyter has to like give people a pre-built environment that has everything to run. This is compatible with QGIS, so if you do have QGIS set up, you can move in between it. But you can basically build dashboards. If you go to that link, you can just click a link and it just opens in Jupyter Lite. Instantly opens in Jupyter Lite by itself. So you can start it. The other thing that they have here is the real-time collaboration. A lot of people are waiting for this in Jupyter generally. Like people are used to Google Docs where multiple people can edit it. So this is possible here. Unrelatedly, but relatedly, they also have Jupyter CAD. CAD's another thing where there's like a monopoly of a company that has a super expensive software. So building Jupyter CAD is like democratizing that, really good for the educational use case. The government's really into this, European Space Agency and NASA. So they have giant data streams of satellite data. They want to democratize those. They don't want satellite data to be locked up. They're like, what does it take for more people to use satellite data? And so this is like making these tools, investing in tools. So this is an exciting moment. Like, is NASA going to invest in Jupyter? Like NASA seeing open source tools and the public being able to use open source tools. That's an exciting thing, right? Because NASA is like usually like contractors and big companies that deliver things for NASA. And this would be the other, like NASA making the public good and like investing in open science tools. All right, so a few API ones. I'm also passionate about this. I really like doing this for my teaching. This is something I've been doing for a few years. If you are in econ, there's a website that's the Federal Reserve. Federal Reserve is St. Louis. And they had this database where you can go and sign up, and I get the students to go sign up and make an API key. So the notebook has a place, and you put your API key into the notebook. And in this case, somebody's made a Python wrapper. And so many of these things that are well used, there's somebody who makes a front end, so you don't have to just deal with the API yourself. So the students have the Fred API package, they specify their key, and they can download data series by data series. So this one is GDP, quarterly GDP. Anybody want to guess what this one is? Can you tell by looking at the time? This is very like pedagogical. Like, can they tell what the different series are? Something that went way up in COVID and then back down. What's that?
Unemployment.
Unemployment. Yeah. If you can see, it's really unemployment rate up there. So this is the unemployment rate. And you can see it spiking during COVID and coming down, staying low. So go get the data series, graph it, combine them. And I will show some more examples of working with that. Unfortunately, students love stock data. Everybody gets stock data. Everybody sort of understands it. This is Apple and Meta. This is the kind of thing like it's on the nightly news that people talk about it. People have their Robinhood accounts, So sometimes I'm like, I'm not going to talk about stocks, but then like half the students in my class want to talk about stocks. So Yahoo Finance has been used for a long time. And there's a Yahoo Finance wrapper. So Yahoo Finance, Y Finance, and you can just, pretty simple, right? So this is getting close to like, the data idea of commands is like single line of code, running one line of code. And can you just change these arguments like stock ticker and dates, right? And then with one line of code, you're getting the data series. And that's getting the data series for 2 equities. This one, a little more subtle, and I was talking about this just the other day this is a graph that I had in class that's sort of like a text classic puts and calls and options, but that you would draw with a pencil. And a little bit of like the vision of my class or what I want my Data 88 class to be is like things that you would learn in an economics class where somebody would draw it out for you. And you would study for the midterm by trying to remember how to draw that graph, right? That's a lot of econ 1, econ 100, a lot is like that. And this is a great example where this is calls and puts for Tesla. And here's like the current price of the Tesla stock. And this is the data graphed going to Yahoo Finance and getting the data and graphing the data. And the data coming from Yahoo Finance is drawing this curve that I would have drawn with a pencil and had in my textbook, right? And somebody was like, oh, why is it all bumpy, right? That's super interesting. You're like, oh, are there just a lack of trades around that number? And like, so that has less information? Or is there somebody doing something and maybe there's a ton of trades around that number and somebody's like thinking somebody's unloading something, there's market going on or market being like thin at these spots. And that's really interesting. So, these are prices coming out of Yahoo Finance that are drawing like what a line I would have drawn in pencil. So I think that's really like a compelling case of what I try to do throughout the class. Okay, here's one of my favorite thing that I did last year. Has anyone heard of the vibe session? All right, 2 people, 3 people. Awesome. There is a social media influencer named Kyla Scanlon, and she was in the Wall Street Journal 2 weeks ago. I heard her on Marketplace, like NPR, and she talks about the economy in a way that makes sense to Gen Z, right? And she makes TikToks about the economy. And I invited her. One of the ways she blew up was she said, we're not in a recession, we're in a vibe session. People think the economy is worse than it is, right? So she came to class, so just really, I don't know if you can see this, but this is from her TikTok, and this is like, no, this is from her Instagram. And this is her teaching. She came as a guest speaker to the class. I was like, I'm going to invite like a TikTok person to class, and the kids are going to think I'm cool. And it kind of worked, but the issue got, you know, how do I say this? She sort of made a comment out. She sort of saw somebody else commenting on Twitter. She made a comment on her TikTok and stuff. She got picked up on the radio. She got put, you know, there's like Bloomberg and stuff, you know, she got put on some of those financial shows. So it sort of like gave her traction. The Financial Times went, so this is like a data reporter at Financial Times. Should we believe Americans when they say the economy is bad, right? People are answering surveys saying the economy is bad. And so it got picked up by real journalists and became a thing. And this is ongoing. So what I did was made a notebook that runs through this argument. And basically, there's if you go to Fred, there's an indicator called the consumer sentiment indicator. And people go out and ask, you know, the government asks people in a structured surveyed way of like a balanced panel of people how they feel about the economy. And so in the data set, this is the blue line is the data set for US consumer sentiment that I went to Fred and pulled down, right? So go to Fred and get the consumer sentiment index and graph it over time, right? And here it is, graphed and not going down to zero. What you can then do is you can build a model. So this is like pretty far into the semester of an upper div class. So I'm not in the data 8 world anymore, right? So I then go and they're like, all right, what's going to predict this? Like unemployment, inflation, you know, other economic indicators, like big economic indicators that people should be responding to. So we can download those from Fred as well, generate the data set, and then make a model that's going to predict consumer sentiment and how good does it do. So this is training the model. So actual versus predicted. So this is, I do it in, also do it in like, you know, linear regression. So multivariate regression, the classic econometrics. And then I do it with scikit-learn and do it with some different machine learning approaches. So it's also an example to compare multivariate regression to other machine learning methods. So this is, you know, the red line, the orange line is you predicting it. And then COVID happens. And then something happens to the model, the predicted power of the model that's basically following the line because it's like inflation's up or unemployment's up or the dollar's low is, you know, some combined weighting of that's doing pretty well. And then all of a sudden, the model isn't predicting anymore. This is just a great, you know, example of like the predictive power of the model is coherent and then it's not coherent. There's a break point. All of a sudden, the predictive power of the model goes away after COVID. People are just pessimistic. So I think why I'm talking about this is for APIs. So what I love about this, you know, most times we're teaching data science, we're like, here's a CSV. Here's a nice, tidy CSV. Start to do your analysis there. This is go to the federal government, pull the data series in real time. Like you can distribute the notebook with nothing else, and it just pulls the data series in it. And then it has the Kung Fu steps like this one's monthly, this one's quarterly, this one needs to be joined by, you know, so you have to like do the steps to pull the data set together to be able to build the model. Then you can do, you know, test train split. You can do test train split by time. You can do multivariate regression or machine learning. And then just the visualization to sort of show how it works. So this was my proudest achievement. And I sent it to the Financial Times guy, and he was like, his answer was, this is the best use I've seen for a notebook. Which I didn't know whether he was like, he hated notebooks. But at least he wrote me back right away, which was fun. And Kyla Scanlon, who knows nothing really about Jupyter, was able to run it all because I had it all like run it and set up in Colab, and she could just run through it and it ran. So that was fun. Okay, how am I doing? All right, I want to end here with this idea of what are we going to do about AI and how we're going to teach students about AI. And where the starting point is at the national workshop, if anybody was there, Pamela Fox from Microsoft came, and she's a former UC Berkeley teacher, but now is working at Microsoft as like a developer advocate, but sort of has her mind like sort of gets, you know, the question of like a student outreach. And she had done this for working in GitHub code spaces, which is another way, if you're interested in teaching, it's like an amazing way to make compute available. So like they just spin up virtual machines right out of GitHub. So she had made this and we looked at it and we're like, oh, that's really interesting. There's like a few things there. And like, what if we could take what she's doing and put that in the Jupyter notebook? So starting point is, can we use the idea that Jupyter sets up your environment for you? And can we make the ability to do what are called these small models? So in the world of LLMs, there's a lot going on. And Hugging Face, yeah, okay. Hugging Face and these other places are where people are running models and releasing them into the public domain. So, you know, the big commercial ones like the Google and the OpenAI, like the giant ones, we don't get to see those. But these, they make small ones, and there's been actually a lot of innovation. Like these small models are getting better and better. Like they're passing all these benchmarks and they're getting better and better. So people are releasing every 6 months like a new small model. And you know, the Facebook has done this. The Llama model is like they make it public. And they make it public in various sizes. There'll be like the 10 billion, the 3 billion, the 1 billion, and the 100 billion or something like that. So some of these small models are small enough that we can run it in the virtual machine. There's a few interesting steps where, you know, it's more complicated because you have to sort of expose. Some of the steps are things you would do to set it up on a command line, like little command line prompts, like go get the model, set it up, read it in. Those are command line prompts. But in Jupyter, it's okay to do that. Like you just put like a, you know, an asterisk or a, you know, and it sends you to the command line. So you can still have nested those things of like read in the model. And in the background, we can put a shared directory where this giant model is ready to go. So if you wanted to teach it with a lot of students, every student doesn't have to download it. It's just like ready for them to read it from a shared directory. And then Ollama is an open source framework that can interact with. And so that's a way to be like, send command, you know, send it to model X and look for this kind of output. So the idea is are getting students the opportunity to sort of touch an LLM model. And we're touching them all the time because we're like using ChatGPT all the time, but it's a little bit like black box that you don't really get what's going on. So this is like, this is all in one notebook right now. I think long-term, we're gonna have to divide it like into several notebooks. But so you go and you're just like, Ollama, I need to set up this Ollama framework, and I'm gonna interact with it from Jupyter sending things back and forth. And I'm gonna set up a path for where my model's gonna be. And I'm gonna see what models I have in there, and it's gonna tell me what models, and I can specify one of those models. So a nice model, 3 billion parameters, phi 3.5. This is a pretty good model right now. And this can read in Jupyter. Remember, Jupyter's like, there's a virtual machine. It's a pretty nice computer, but it doesn't have GPUs. It's just CPU, right? So it's not like training the model. It's just reading in the what we call the model weights, right? And then this sort of chat client and telling it where we're gonna direct it to, and we're going to direct our answers, our questions and responses to it. So the first is like, can I send a message? So when you specify message, you say, can you write a haiku about the Learning Lab Inspire convening? So this is the user asking something. Temperature is really interesting. You can change the temperature of the model. That's like how far away it goes, you know, or how much it hews to the original prompt, like repeat something closely back to the prompt or like go crazy. That's the temperature. So that's sort of little things that can be changed. And we've done phi 3. So this is use phi 3, temperature 0.7, and ask it this question.
Inspire. Still works.
In SciPyre. All right. Minds bloom like flowers. Learning lab whispers inspire. Knowledge's dance begins. Phi 3.5 for the win. So I will do it again. This is a slide, but I can go after we do this. We go to the question and answer, and I'll do it again. Or we will write it. What's that? We can keep hallucinating. All right, system message. Does anybody know system message? This is a big thing in these LLMs, right? System message is like, when you go to ChatGPT right now, they're like, download this custom GPT. That's like the one that's going to do X, Y, Z. That is a system message, right? So basically what that is those ones that you can be like, get a custom GPT. Have you guys seen this? Yes. So those are system messages, right? And here it says, this is a weird one. Sorry. Dobby is a small, friendly household who lives in a Hogwarts castle garden. He has an irritating habit of speaking in short, clipped sentences that are difficult to understand. Please role play as Dobby, right? So that's like a weird, fantastical, but you know, engaging to a student probably, right? They're all Harry Potters still. So, and then the user message is, how are you? And Dobby says, bright, I am not, am I not today? Rain, it is raining heavily. So, you know, the model is now speaking like an elf who lives in the garden. So this is a fantastical prompt, but you can imagine that this is the kind of thing where those custom GPT, this is you making a custom GPT. So we are kind of, for me as a user, I'm like prompt engineering, how to make my prompts good, how to get the answers that I want. But, you know, who was the people at lunch that were like, we have $8 million to build a chatbot for you, right? They're doing the system message engineer. Like, that's like, they have an LLM and they're building like a specific chatbot for you. This is the stuff they're working on and fine tuning, right? Finally, well, there's a few more things. Another one is a system message and a few shot. So a few shot is you give some examples, right? Sorry, this is so small, but you're a helpful assistant that helps students with their homework by asking questions. So you don't give the answer, you ask another question that will lead students towards it, right? So this is the kind of thing that universities are doing. Build a chatbot based on my last year's ed, you know, or Piazza questions that's going to answer the question, but don't actually answer the question, ask another question that will lead them toward it. So this is in the system message. And then it says, example, what is the capital of France? Here is a question to help you work it out. What is the name of the city that's known for the Eiffel Tower? Right? That's a few shots. So give the model a few examples of the things that it should do. So system message plus a few shots. So the question is, what's the largest planet in the solar system? And the TA, the virtual TA chatbot that we're all making right now, here's a question to help you work it out. Which gas giant, for its prominent rings and massive size compared to Earth, holds the title of being the biggest planet, right? So I'm being pedantic, but I think, you know, like, this is like exposing these elements to the students that like our whole economy is in a fever pitch and all of the venture capital is going into this, right? And so this is like in a few steps exposing them to this. This isn't going to make them like an AI engineer, but this is going to expose these steps and give them some familiarity to it.
So this one, like, does it actually like retrain the weights, or how does the system message and the examples work?
So the system message, the weights don't get retrained. Like 5.3.5, the model is there. And you are sending like through that neural net weights, like this set of information, and then this question. And this is what comes out. And so like OLLAMA is a way that allows you to say, system message, send that into the neural net, few shots, send that into the neural net, question, send that into the neural net. And then it'll like say what the model comes out with.
So can you like feed it some kind of a, you know, let's say your classroom materials?
Yeah, that's the point, right? So last thing that we all need to learn, RAG, retrieval augmented generation. So this is the last step that we need to learn. And this one is a simple one that was like, you're a helpful assistant that answers questions about hybrid cars. And then you say, hey, model, read this CSV, hybrid.csv. And that's going to have car models and how much miles per gallon they are. And the question is not on here because it's too long. But the question is going to be like, how many miles per gallon does the Prius have, or something? What's more efficient, a Prius or a Camry, or some one of those questions. So you have read, this is RAG. So this is the work here. Is the, you know, read my last year's questions and answers from my homework, right? Is RAG. And I had a side project that I'm working on for this that's, so data 8 textbook, and my 2 classes each have a textbook that are in Jupyter books. And Jupyter books are a combination of Markdown and Python. And you can just pull the Markdown out and make that into a tokenized text to read. So there's some steps here that's like natural language processing. I'm like totally embarrassed because John De Niro's in the room and I'm talking about this, but this is basically using just, you know, matching words directly. That's not using a natural language tool. Usually for this, you do a step that's tokenization, that there's another Python package like NLTK, or there's other Python packages where you throw a bunch of words into it and it finds things that go together. And then you send those into the model, right? You've trained like, oh, what words are proximal to each other? And you send that into the model. This is just a really cute, simple one that's just like pattern matching based on text alone. But this is the work, you know, this is what are the steps to like take my questions and answers from last year or my email inbox, and I was thinking it was cool because so many data science texts are in Jupyter books that you could make a generic one that says, read this book, right? And they're all in GitHub repos. So you could say, you know, there's probably 100 data science books in GitHub repos. And you say, go to this GitHub repo, get all the notebooks, pull all the Markdown out, tokenize the Markdown, and read that as a RAG step. So that would just be like an illustrative way to be like, here's the steps, go get the corpus, tokenize it, and send that in. So yeah, that would be like the last step, is like how to train your model to read a corpus.
And how long does it take to train?
It can take a while. It can be slow. Like this isn't super fast on Jupyter. It's like you have to wait 15 seconds. It doesn't like instantly start writing it or anything. And you know, the steps of like dealing with the data and tokenizing it and running the neural net or whatever you're doing to tokenize that, those will take compute time. But for me, just like that it fits on, you know, what I think of as like a small amount of compute is a Jupyter notebook. And then we can do this like thing that's, we're told is like the big boy workflow that's eating like 1/10 of the planet's electricity or something. And you're like, oh, we can do this like tiny sliver of it for teaching purposes.
So are you teaching this in class, or is this something you're doing to kind of prepare yourself for the class?
Yes.
I'm excited about the future. And I'm like pitching this. So one part of it is like NSF, near classroom, right? They're like, people want to figure out how to teach AI. Almost everything is like, it used to be like data science, data science, data science, and now it's AI. But I feel like people don't really know how to teach AI yet. And I'm like not really somebody to tell anybody how to teach AI. I'm not a computer science professor, but my goal is to make this into 6 to 10 awesome notebook. This is just how I think about the world right now. If I could make this notebook into like 5 or 6 awesome notebooks, that could be the framework of a class that you try out with the first few students for the first time, and you keep building it, and then you build the labs, and then you build the applications. So this is how I think about curricular development. Build an awesome notebook that's engaging. Build the teaching notebook, that's the exposition, and then think what's the coding challenge for the lab, right? So this is just like me internalizing this workflow that I've been taught, and then I built a couple classes on, and this is me thinking like, I think this is the future, this is the future class. I mean, it's a weird world with this AI thing. Like, so we have a community college, Laney College, that we work with. And we're like getting them to teach data 8. And my pitch is like, okay, if you want to learn AI, start with data 8, then go to data 100, then take like the neural nets class, and then you're going to be towards AI, right? But there's somebody else at Laney College who's like, I'm going to start a certificate in AI, and I'm going to teach 18-year-olds with no math class AI at 18, right? And so I'm just saying, like, there's a weird thing going on about AI right now. And sorry to call it Laney College, but I'm just like, it's just like a weird, you know, I think there's a progression to get to AI, but then other people are like just throwing up in the air, like, everyone's gonna learn AI, or everyone has to learn AI, and if we don't teach them AI, we're doing them a disservice, you know? A lot of that, I think, is more like, what's it like to interact with a chatbot and how to do prompt engineering, and you'd be missing out if you didn't learn how to interact with a chatbot. I use it to code all the time, you know, and like, so the students are gonna need to learn that. But I think this is the backbone of the future class.
What kind of data do you collect from the learners' interactions with the things you are having them do that allow, and how do you model those data to get insight into whether or not those things you're having them do are actually supporting them to build the knowledge and capabilities you're designing this to support them to build?
Clarification, are you talking about like the LLMs or just
Human learners,
learners in general?
the human learners.
Yeah, no, sorry, but I mean, specific on the LLM conversation or just generally about Jupyter?
You can take that as a specific example,
Yeah,
but generally.
yeah. We don't, like, this is definitely like, something I dream of having is more telemetry. What we do have in like the learning science side is we have this auto grading approach where the learners are in that and they do, you know, so suppose a lab is set of like 15 or 20 coding challenges. And I've written in the text box how to do the coding challenge, and then it's like variable equals, and then they have to fill it in, right? That's basically where we are. And then there's auto grading that then says you did it right, go to the next step, or you did it wrong. And sometimes you need to do part A right to do part B and part C. So it's better. It's like first. This is all coming from learning science on the computer science side. Is like students need real-time feedback. They need real-time feedback. That's like adding, making the additive chunks, right? So we don't have telemetry right now. We have tried a couple projects on telemetry and they have been fiddly. But what we really should do is while we're doing those checks, like, you know, they try it and then they run the grader and it's wrong. And then they go back, like we could be logging those. And then there could be a log that's like 75% of the people made it through check 1, but 50% of the people made it through check 2. And then 50% of the people that tried check 2 again got it right the next time. You know, like it wouldn't be that hard to generate like a telemetry, a simple data set that would just give us like how people progress through a single notebook. But we don't have that. There's some architectural questions. So I'm pretty into like the notebooks are light, the setup is light, and they work anywhere in the world on anybody's servers. And as soon as you're like, it has to be hooked to a certain API, to a certain thing where you're logged in, and student data is very special, and only some people can see student data. Then you're building an LMS. Then you're out there in the lobby getting money from a corporation to like build something that's like students are logged in and their telemetry is logged in our system. And I'm more like, let's build light notebooks that anyone in the world can use. Because I think my impact is bigger that way than building a walled garden system. That's sort of philosophical, I think, but
Those aren't the only choices.
those aren't the only choices, but I'm like leaning to, yeah. So I have seen when, let me say, there's a bunch of Jupyters on LMSs, right? And each of their grading and telemetry systems is proprietary to each of that system and doesn't easily move across systems. So, how do we make the telemetry system be light enough that it can be like, basically the requirement is like pip install tracker or whatever it is that we're doing. And then the person who's running the system has to be responsible to take care of that data and stuff. So I don't have it. I have a lot of ideas of how we could do it. And I think it could really interact with our lightweight grader package, but there's a headache around who has the data, where is it, how do you take care of the data? There's a bunch of stuff like that. That gives me pause.
I guess I wasn't as interested in using it to evaluate the individual learner as.
Well, I want to do it to individuate the lesson
Yes.
or the coding challenge. Like, is this a good coding challenge or a bad coding
What
challenge?
degree does that actually
Yeah.
support people or whatever it is you're trying to do?
Yeah.
You had a system, right?
Yes, CMU has a really cool system
Yeah.
to do this,
Yeah.
and their stuff is
On the
open.
statistics side.
Yeah,
programming per se, but maybe it can be tweaked. for
Yep,
Programming. language.
totally. But they run a server and they have like a bunch of grants to keep that server running and stuff. So. And you as the user have a login and your students have logins.
Well, the vision behind Jupyter was Julia, Python, R.
Yeah.
And yet, your talk was 100% Python, so. What's your take on the, language, this Quarto building an ecosystem for R kind of, parallel, so is Jupyter now same thing as Python or? Only Python?
No, so we support R a lot. So I would say at UC Berkeley, 10,000 users a semester, 2,000 are in R. So it supports both. It can support Quarto, so because it launches our studio and you can support Quarto. So one of our biggest classes is Stat 20, like the gateway to econ and all this stuff. The class everyone has to take for a bunch of social science majors. That's all run with Quarto in our studio on the Jupyter Lab, Jupyter Hub. So Jupyter Hub is also just like a server that's really easy to authenticate a lot of people, give them a tiny access to a little bit of a virtual machine, and they can have our studio in that virtual machine instead of Jupyter as the IDE. So what's the rest of me answering your question is I think they're all both going to travel together. Jupyter supports like 80 kernels now, like there's tons of kernels. One thing we haven't chased is like, I do a lot of like trying to chase down like MATLAB and Stata and get rid of those, right? So there's a Stata kernel, but that's complicated because then you would have to have like some sort of licensing, and the people, they keep saying they don't want to support the Stata kernel because the way they do the DevOps development is like completely transparent, and then it like might be like somebody unlicensed could get it. What's interesting is MATLAB you can replace with Octave for most things. So like there is Octave for MATLAB. We haven't built it, it's just a matter of time, but like if we need to chase down some MATLAB people and get them off MATLAB, there is like Octave kernel in Jupyter as a possibility. So I still think there's a lot that the tool can do to be in multi-languages. All my stuff's online in public GitHub repos that I teach. There's DF modules GitHub repo for a lot of other classes. My classes are Data 80 and Econ 148. Everything's there. The Olama demo, if you write me, I can send it to you. It's on, if you go to the DS modules repo, it's on there. GitHub DS-modules and look up Olama, and that whole demo's there. Which I could bring up. I don't know. How are we on time? What's that? Should I do the live demo? I think I'm out of time. Am I out of time?
We're gonna run the haiku one again.
Yeah.
Yeah. What's the prompt?
I'll say that.
Yeah, that inspired.
This is the elf. Okay. Oh, dude, but see, the kernel died. This is what happens to me when I teach. I get all the windows ready, and then I go in there and teach, and then I talk too much, and when I open my demo, my kernel has died, and I have to restart everything. Okay, so where do we start from? We don't want to, so yeah, we have to go up here and run a bunch of stuff up here. Oh, yeah, so I have to. This is me exposing the command line here, right? It's like pwd ls. This is like, show the students the tree that they're in. And it's like over here, you're like, oh, here's this thing that I was downloading. Oh, 3 billion parameters, 3.5. Hey, can you run 3.5? So this is, you were like, how does it read the model? Like, what is all this code doing? It's beyond me. All right. Go to 3.5, import OpenAI. All right, what was the new prompt for the, wait, this is the existing haiku, but what did somebody want to change the haiku while we're here? It's thinking, but let's change the prompt for the next haiku. Anybody? Prompt?
Reception.
What's that?
Yeah, write a
What was
haiku
that?
about the reception on the roof.
Oh wait, this is second. Wisdom flows in spring's breeze, inspire minds blossom free, lab learns with such ease. Is too similar?
Well, same vibe.
Okay, write a haiku about the reception on the roof. So it takes a while, but this is a little bit interesting. It's down here. So it's not using all the memory. I got 4 gigs of memory and it's using 200 megabytes. So interestingly, somehow it's like constraining itself, which is good because we had a problem with Data 100 where we ran a big transformers model and it used way too much memory. So that's like a whole interesting part from the educator side is like how to engineer your work so that it fits, you know, how to give students access to big models and big data sets, but keep it so that the compute runs on the server. Okay. Steel against soft blue, gentle whispers in high breeze, rooftops cradle. Hearts meet with each synergy leapfrog greeting. That's a pretty weird haiku.
Made that work.
It's misspelling something. There you go.
Yeah, but what's
Well, we even in humans, the right
Sun-
haikus about
sun-
conferences.
Never.
sun or green? Sun is it? Sun are like long.
All right,
So
this,
is 0.7 like too far away?
yeah, 0.7 is, yeah, or too low. Is it too low or too high? I think I'm out of time, is that correct?
Yeah.
Thank you very much for coming and listening to me blabber.